Okay, so sorry for the delay. I woke up at 8 just to record this, but then there was some technical difficulties. My iPad was not charged. So I had to spend the time charging. Okay, so I need to chop and finish this because I'm going out soon. Okay, question 1. Which of the following is true about ethanol? So I've drawn the structure of ethanol here. A, it says it's an unsaturated compound. That's not true because there's no double bonds formed in ethanol. B, it is formed by the oxidation of ethanoic acid. No, when we oxidize ethanol, then we get ethanoic acid. So B is false as well. C is formed by the catalytic addition of steam to ethene. This is correct because now here is ethene and here is water. How it works is it will join like this. So that will form the alcohol that you see here. D, it reacts with ethyl ethanoate to form an acid. That's wrong because ethanol plus ethanoic acid gives you ethyl ethanoate, not the other way around. Question 2. Which of the following is true for butanol compared to butane? Okay, butanol and butane, I drew out their skeleton here. So as you can see, the difference is just the hydroxyl group. So the difference would lead to a difference of hydrogen bonding being there and not being there. Okay, so because of this, you can tell that butanol will have a higher melting and boiling point, whereas butane will have a lower melting and boiling point. Because it has a higher melting and boiling point, it is less volatile. Okay, so we are left with C and D. Then we also know that butanol can take part in hydrogen bonding with water, and butane cannot. Therefore, it is more soluble in water. I think somehow there's no in water. Okay, that's what they mean. Question 3. Ethanol is used in some aftershave lotions and deodorants. Which pair of properties makes it suitable for this use? A, it is flammable. Oh, it's not good to be flammable, right? So out. B, it's a good solvent and vaporize easily. Okay, this is true. We want it to vaporize so that it can, spread on our body. You don't need it to be like liquid, like sweat on your body, right? Okay, C, it is colorless, and colorless is good. Okay, and has a low freezing point. Okay, low freezing point is not so much of a concern here because what we want it to do is to vaporize, so we want the boiling point is more important rather than the low freezing point. Okay, D is flammable. Again, flammable is not good, so out. Question 4. The structure of three compounds P, Q, and R are shown. Which of them are isomers of each other? So to be an isomer, first they must have the same molecular formula. So that's what I did here. I wrote out the molecular formula for P, Q, and R. So you can see that they all have the same molecular formula. Okay, next, we see about that they all actually have different structures. P is an ether, which makes it an isomer of alcohols straight away. Okay, then Q and R, you can see that they are positional isomers. They differ in where the hydroxyl group is placed, so therefore they are all isomers of each other. Answer is D. Question 5. What conversion does the process of fermentation involve? Okay, this is the anaerobic respiration when we are converting glucose to carbon dioxide and ethanol. Okay, this is to evolve energy. Answer is D. This is just a recall question. Nothing much to go through. Question 6. Answer is D. Propene. Because only alkenes react with steam to form an alcohol. Answer is not B. Okay, question 7. This is the one that is a bit confusing. Question 7. Hex 3-ene-ol has 3-in-1-ol, I think, has a strong leafy smell of newly cut grass, structural formula as shown below. So I drew it out. Okay, usually when they give structural formula, right, I like to draw the structure so that I'm clear exactly what am I reacting. What is produced when hex 3-in-1-ol is treated with an excess of hot concentrated potassium manganate 7. Now we learned that potassium manganate 7 would oxidize the alcohol group. Okay, oxidize the hydroxyl group. I think what is missing in the question is also acidified. It's okay, add it in. Acidified potassium manganate 7. Okay, so what happens is it will actually oxidize your hydroxyl group to a carboxylic acid. So that's why you will get the answer B. But what you did not learn in class is that actually alkenes can also be oxidized with hot acidified KMNO4. So what happens is this. You see this double bond here? It will break this apart and form 2 carboxylic acids at that side instead. So actually the answer is D. In real life, the answer is D. But because what you learn only allows you to conclude that B is the answer, so therefore I will accept both answer B and D. Okay, if you are advanced and you read out on it yourself, maybe you get the answer D. Okay. Next. Question 8. Ethanol was oxidized to ethanoic acid using the apparatus shown below. So this is the apparatus. What is the purpose of the condenser? Okay, this is actually heating under reflux. Okay, so this is what we mean by we heat under reflux. First, when we heat it up, okay, whatever's inside here will vaporize once the temperature is high enough. It reaches the condenser and it starts to condense back. So this is a cycle, up and down, up and down, up and down, up and down. So we call it reflux. What's the purpose of this condenser? I think you can intuitively understand. It is to prevent the escape of any unchanged ethanol. Okay, so any unreacted ethanol will condense back and it will react. It will be given a chance to react again rather than just escaping it into the air. Question 9. Which of the following reactants and/or conditions will produce 2-bromopropane from propanol? Okay, this is an interesting question in the sense that we have the start, we have the end. What must we do to get to the end? Okay, so we know that this is an alcohol, then this is an alkyl halide in the center. So this is where your reaction map comes in handy. Try and find a reaction that connects from an alcohol to an alkyl halide. What reaction do you see? It must go through an alkene. So what happens is we must first dehydrate it with H2SO4, then we add HBr, so answer is C. Question 10. The structural formula of butene-dioic acid is given below. Which of the following statement about butene-dioic acid is not correct? Okay, note that it's butene, which means that there's a CC double bond here. Okay, dioic means there's 2. Dioic means that there is 2 acid group. A says that it's an unsaturated compound. That's true. There's CC double bond. There's also C double bond O, so it's unsaturated. Next, B is empirical formula is the same as its molecular formula. Let's check. Now, molecular formula is C4H4O4, which makes its empirical formula CHO, CHO. Therefore, B is false. Okay, C and D is very easy to check. D is correct because there's a CC double bond. It will decolorize bromine. C, I never calculate, but it should be correct. Okay, 11. An organic acid has the structural formula as shown below. Which of the statement is incorrect? A. It burns in air to form carbon dioxide and water only. This is false because I don't know if this is very noisy because my mother is washing clothes now. Okay, try and bear with it. Okay, which of the following statements is incorrect? Burns in air to form carbon dioxide and water only. This is false because to form carbon dioxide and water only, I need to have C, H, or O as the only elements. Right? Because the product CO2 and H2O, there's only these 3 elements. Now, but here we have chlorine as well. So that will be one of the product formed that will not be just carbon dioxide and water. D, it decolorizes aqueous bromine. This is true because of the CC double bond. C, it turns blue litmus paper red because of the acid functional group. Okay, in blue. D, it reacts with zinc to produce hydrogen gas, again because of the carboxylic acid. 12. An organic acid decolorizes aqueous bromine. So, since it's an acid, it must have a COOH group. Since it decolorized equals bromine, it must contain the CW1C group. So if we put these two together, the only answer is B. Question 13. 20 cm³ of a 0.1 mole per dm³ citric acid with the formalin structure is reacted with an excess of zinc metal. Okay, so to do this, we need to look out for the number of carbon of the COH groups. Okay, that will tell us the number of moles of H plus that is produced per molecule of acid. Okay, so there's 3, it means that it's a tribasic acid. So the number of moles of hydrogen that can be produced from 20 cm³ of 0.1 mole per dm³ of citric acid is 20 cm³ times 0.1 mole, the concentration. This will give me the number of moles of citric acid, but I must times 3 to give me the number of moles of H plus ions. This is 0.006. Now I wrote the ionic equation here for the reaction of zinc with hydrogen ions. So note that 2 hydrogen ions give me 1 hydrogen gas. Therefore, the number of moles of hydrogen gas is half that the number of moles of H plus ions, so it's 0.003. The volume of hydrogen gas is then just times multiplied by 24,000, which gives me 72 cm³. Question 14. An aqueous solution of a compound of molecular formula C2H4O2 react with sodium carbonate liberating carbon dioxide. What is the structural formula of the compound? So since it reacted with sodium carbonate to give carbon dioxide, it must be an acid-carbonate reaction. So therefore, we know that it must be a organic acid. What is the structural formula of the compound? Just look out for the one with the acid group, and answer is C. Question 15. An organic compound Z reacts separately with sodium hydroxide and sodium carbonate, which means that Z is an acid again. Which of the following can represent the structure of Z? Just look for the one with the acid group, answer is D. Question 16. An organic compound X has the empirical formula C2H4O and a relative molecular mass of 88. It reacts with ethanol in the presence of concentrated sulfuric acid to give a sweet-smelling liquid. Which of the following structures could X have? First, we must find out what's the molecular formula. Since they gave us the empirical formula and the molecular mass, we are able to find out what is the molecular formula. Okay, step 1. Find the MR of C2H4O. Okay, now somewhere is having construction at the house above me. Okay, no more sound. So we can just find the MR is 44. Since it's 88, I know that everything must times 2. Therefore, the molecular formula is C4H8O. And it is a carboxylic acid because it reacts with ethanol to give an ester. Therefore, putting everything together, answer can only be D, which is the acid, and satisfy the formula. 17. A chemical analysis done on blah 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 octyl ethanoate. What is most likely the use of octyl ethanoate? This is an ester, therefore is for flavoring. Question 18. Which of the following is the correct formula for the ester formed when butanoic acid reacts with methanol? So again, given the structural formula, I draw out the structure so I can see the reaction better. Okay, there's butanoic acid here, and then there's methanol here. So we just draw what is the ester form. It will be this. Then you convert it into structural formula. We get D. Okay. Question 19. What is the constituent of BUX has that formula? I'm not going to draw this out because it's CH2 times 24. Okay. So how can you see this? How can you see what's the product of this hydrolysis? Look out for the COO group. Okay, COO group tells us that it's an ester. Note that one of the O belongs to the carboxylic acid. The other O belongs to the alcohol. So, based on this, we cut it in half. We can see the acid part will have CH3, CH224, COOH, and the other side we have a CH3, CH224, 8COH, 29OH. So answer is C. Okay. Question 20, last one. Okay, before the construction continues. A compound acts as the properties as follows. It is a liquid at room temperature and atmospheric pressure. It has relatively high melting and boiling points. This is a liquid. It does not mix completely with water. It means that it's not an acid, not a small chain alcohol. And it also does not decolorize acidified potassium manganate 7. It's not a alcohol, not primary at least. Which of the following could be X? Therefore, the answer cannot be ethene, because ethene is a gas at room temperature. Cannot be ethanol, because ethanol would decolorize acidified potassium manganate 7. Cannot be ethanoic acid because it mixes completely with water. Therefore, we are left with the answer D, ethyl ethanoate. Okay, so that's all. And we will see you for worksheet 15. I don't think I have time to do it now, so sorry, it will be uploaded by tonight. Okay, thank you.